Hey everybody, so what I'm going to work on now is I'm going to work on describing how I'm going to go about building my wind turbine, or how I'm going to make those decisions on what I'm going to make my features for my windmill. And so I've got 2 pages open here on my desktop. I have the windmill project overview, the original slideshow that I showed you. And on slide 7, you have the design choices. Now these are just features of the windmill that I can use when I generate it. And this is the wind turbine calculations. It's the spreadsheet that I shared with you in order to calculate the amount of money I'll make with my windmill. So over here, I will come over to these features, and this is where I'm going to type in my answers to the features that I'm going to decide on my slide 7 over here. So if I start here, I have to take a look at the different features that I can choose from. And so the first one here is the blade length. And it says the measure of the blade from end to end. How long is the blade going to be? And I can choose 37 meters, 40 meters, or 45 meters. Now remember, I have a lot of things to think about. I want to gather wind, but I don't want to make it too heavy. But maybe making it long is a good way to go to gather the wind. Maybe it would offset the extra weight of the fan blade, particularly if I'm doing it in an area that doesn't have a lot of wind. Maybe that would be a good way to gather more of that wind. I really don't know. And I'm not sure that there is a way for me to find out without running some kind of an experiment. We're just not up to that yet. So I'm going to make an arbitrary choice here, just a random choice. I'm going to say the length is going to be 37 meters. And so I'm going to come over here and I'm going to write 37 meters in my blade length. And then I'm going to find a pitch. Now, the pitch says the angle of the blades on the rotor. So if I've got a rotor like this, right? I've got my rotor, and I've got my blade that I'm going to put on top of it. What sort of an angle is that blade going to be at? Is it going to be set at 5 degrees, 10 degrees, or a variable one controlled by a computer that will rotate it to its peak efficiency, but will increase the cost dramatically because it's another mechanical part that can break, and it's also expensive to install and maintain. So I'm going to take an arbitrary number. I'm going to say 10 degrees, because why not? Okay. Now the blade twist, again, this says now the blade twist is built into the blade to equalize the lift. The pitch angle is greater at the hub than at the tip, which means now it's taking the blade, if this sticky note was my blade on the rotor, it's taking the blade and twisting it some, so that the blade actually has a twist in it. A better example of this might be my fan over here. These blades are twisted some, so they have a minor twist in them. Would twisting the blade, how would that affect the way that the blade is moving through the air? So do I want it tipped or not? I have to decide. I'm going to say yes, because why not? It's the first choice. I'm going to go with it. Now, I would like you to defend the choices you make with why you think it's a good idea. So don't just think that you can just do what I'm doing and just grab them and go. I want you to defend them with your own reasoning. Now, the next one is the tip shape. What do you want the tip of the blade to be? Should it be wide at the end, or should it be a thin, narrow tip? Again, I'm going to go thin, because maybe it'll save some weight, and maybe I don't need it there. Maybe I do. I don't really know. And the airfoil shape is like if I took the blade now and I cut it this way, what's it going to look like in profile? Is it going to be really wide? Is it going to be thin? Or is it going to be super thin? Or, I'm sorry, thin, thick, or super thick? Now, I'm going to say thin, because I already said thin on the one above. But it's important that I kind of point out It's important that I mention this, is that the way your blade works is like a wing on an airplane. And the way that an airplane blade works is to make the air different above and below. So you have a plane wing looks like this. Now the distance, this distance up here is much higher than this distance. This is a straight path from here to here. This is a curved path from here to here. So it has a longer distance to travel across the top than it does across the bottom. What that means is that the wind under here is moving faster than the wind over here. And it creates a vacuum above the wing, which makes the air under here push up on the wing, creating something called lift. And that gets the wing off the ground because there's less air molecules up here as these things are spread out more. I should say it's less dense above the wing and more dense below. So it pushes the wing up, almost sucking the wing up into the air. And so that's the way your fan blade works. So when I look at the airfoil shape, what it's asking me is, let me get to the stage of this and I'll show you the picture, is it's asking me, what does the cutaway view of my blade look like? Is it thin, or is it super thin, or is it thick, or is it thin? What size is it? Because if this is the size, it's going to create a bigger difference. This is a bigger distance to go across the bottom. It's going to have more lift and it's going to move faster, but it's also going to be heavier. So again, you have to weigh the benefits of both. Is it better to have a thicker wing, or is it better to have a lighter blade? So, and I'm realizing now that this is wrong. It says super thick. It should say super thin. So then the turbine height. I'm going to put in 80, 100, or 120. Let's just call it 80. And then these 5 products are the 5 products that 3M, a company that manufactures parts for windmills, they make these epoxies and tapes and things. And I can use them to modify the blade. For instance, the first one, the matrix resin, increases the strength, toughness, and durability of composites, or like the materials I make my windmill out of, while reducing the weight, which means that I'll have a stronger, tougher blade that's going to require less maintenance, but it's also going to be lighter, which is awesome because that's going to reduce the weight. It's going to increase the cost a little bit because I'm going to have to pay for these extra high-priced pieces, but it's going to reduce the weight. The riblets film provides improvement in drag reduction in a passive manner for any high-speed vessel without adding significant weight or complexity, which means that this is a film they're going to put over the top of the windmill blade, and it's going to reduce the drag, the forces that slow it down. It'll slip through the air easier, so it'll go faster without really adding any weight because it's just a film on top. The filler is a polyurethane filler used to finish, smooth, and repair wind blade surfaces. So this is an extra coating on the outside. It's going to add some weight, but it's going to also smooth the finish on it so that it travels faster. And the wind blade bonding adhesive is an epoxy paste adhesive, which means they take 2 chemicals and mix them together, and it turns into the most powerful glue you can imagine, and it turns as hard as steel. And they use that for putting the wind turbines blades together. This high-performance, toughened adhesive combines outstanding shear and peel strength along with excellent durability, which means I'm not going to have to fix these things forever. They're going to be rock hard. Also going to be significantly heavier and more expensive, but my maintenance costs over time will be reduced, and that's all going to get calculated into this model. So I get to pick these 5 things. Do I want to add any of them, all of them, none of them? I get to pick. So kind of see what you think works and what doesn't. And again, you might just be guessing, but you can make a reasonable guess at how many of those you think will be worth it. And that's how I'm going to design my windmill. So do all of that before you run the simulation. Pick your pieces and put them into the slide, into this page here. You can just put a yes or a no. In these things, I'll add the resin. Oops. And I won't add any others. I'm going to say no to the rest of these. Actually, let's say yes to the filler. Why not? And we'll say no to those and no to those. And so now that I have all these pieces of information, the next thing I'm going to do is run the experiment and put this into the plains, hills, and offshore. But actually, that's wrong. The next thing I have to do is plan the experiment and do my variables and my hypothesis, and I'll do that in the next episode.